Hi guys, today's video notes are on 10.4a and we're going to be talking about the probability of disjoint and overlapping events. So our essential question is, how do we find these probabilities? And first we need to talk about compound events. And compound events are when you consider all outcomes for A and B, you form the union of A and B. If you consider only the outcomes shared by A and B, you form things called an intersection, right? So there's a difference of like union is everything. Intersection is what intersects between A and B. And things that are unions or intersections are called compound events. Okay. So all of these are compound events. Now, let's break it down once we have this general idea, right? So this is union of A and B, right? So all of this is happening, and here we're only covering like what they both have, but this last one, if they don't intersect, then there is no intersection, okay? So today we're going to talk about how we can find P of A or B. And if we do that, we have to consider if there's intersections, right? Because if I'm talking about A or B, that means we're not talking about this one in the middle. So they are, two events are overlapping when they have one or more outcomes in common. So this one's overlapping. And two events are disjoint or about that, mutually exclusive when they have no outcomes in common, as shown as this one, right? So this is disjoint. So let's look at what the probability of compound events are. If we're talking about A or B, we're going to take A plus B and subtract the overlap. Okay, now there's only overlap in this kind of situation. If there's disjoint and there's no overlap, then you don't need to bother to subtract. Like, you can try to subtract it, but there's no overlap, right? In this box, let's write down what happens when we have the probability of A and B. Okay, so notice A or B, we're adding the probabilities. A and B is multiplication. If we wanted to talk about independent, that's this one, right? And then if we wanted A and B dependent, then we have to talk about probability of A times the probability of B, given that A has already happened, right? So there's your conditional probability. So let's take a look at how this can show up. So in example 1, we're going to talk about a standard deck of 52 playing cards, and we're going to select one card at random. What's the probability that the selected card is a 10 or a face card? So the first thing I'm going to do is write probability of 10 or face is J, Queen, King. Okay, just so that helps us decide. So the probability of getting a 10 out of my deck of 52, right, is, let me just write the formula down because that'll help us. Okay, so we're going to take the probability of getting a 10. We're going to add the probability of getting Jack, Queen, King, right? And then we have to decide, are there overlaps? Can it be 10 and Jack, Queen, or King? And that answer is no. Okay, so I'm going to write no overlap because cards cannot be 10s and Jacks. So probability of 10 is there are 4 10s out of the 52, and then there are 4 Jacks, 4 Queens, and 4 Kings for a total of 4 plus 4 plus 4 is 12 out of 52. And so when you add these together, you're going to end up with 16 over 52. They can both be divided by 4. So that'll be 4 over 13. Okay, so start to get comfortable with dividing by 4 because you know 52 divided by 4 is 1 suit. That's 13. That's going to be equal to 0.3 sorry, 308. Let's do 30.8%. Okay. So let's take our next problem. What's the probability that the selected card is a face or a spade? Okay. So that means I'm going to take the probability of a face card plus the probability of a spade. And then we have to decide, is there an overlap? Can you have a probability of the spade and face cards? It doesn't matter which one I write first. Okay. Now, spade and face cards means there are a jack of spades. Oh, I should have done hearts. That's this one. A queen of spades and a king of spades. So you guys okay with that overlap? Okay. So I'm going to have 12 out of 52 face cards. We already talked about that up there. We're going to add spades. There are 13 spades out of the 52. But then I have to subtract the ones that overlap, right? These two are double counting jacks, queens, and kings of spades. So I have to subtract 3 out of the 52, which gives me a total of 22 over 52. Okay, I can reduce, divide by 2, and divide by 2. That's 11 over 26, which is 42.3%. So the question you have to ask yourself is there an overlap, right? And you have to think about that in terms of the problem I'm giving. So I'm going to have you try this last one, see what you get. Okay. We'll check our answer and just make sure that's what we've got before we move on to the back. Okay, so before you go to the next page, I'm going to show you the answers on the back. So please go to the back and try C and D to talk about like if there's overlap or not, or if it's disjoint. Sorry, I should say that. And then pause your video right now and unpause in a moment to check your answers. So notice in the first one there's no overlap because 5 and 10 are multiples of 5. Never count face cards if we're talking about numbers. Multiples of 3 are 3, 6, 9, and there is no overlap. Versus if we do 2 and a black, there are 2 black 2s, 2 black 4s, 2 6s, 2 8s, 2 10s, and that'll be 9 over 13, which is whatever percentage you get there. Okay, so I'm going to have you give me that percentage. So let's move on to example 3. This is where we're using a formula to find P of A and B. So please remember that A and B is when we are, well, actually, let's see what we're given first before I talk about what formula we're going to use. So out of 200 students in the senior class, 113 students, so let's write it out on the side. Ready? 200 total. 113 are either varsity athletes or on the honor roll. So 113 is varsity or honor roll. Okay. There's 74 seniors who are varsity athletes. Okay. So, oh, and we're talking about seniors only, so this is not a conditional. So there's 74 varsity, and then 51 honor roll, right? And then what's the probability, let's see what we're being asked, that a randomly selected senior is a varsity athlete and on the honor roll? Okay, so what we're looking for is P of varsity and honor roll. Okay, this is what we're looking for. And so if we look at what we're given, we have ors, we have each of them, right? And so we're probably going to use a formula that has an or, which means we're going to be using this formula right here. Probability of A or B equals the probability of A plus probability of B minus probability of A and B. Okay, and so if you take a look at it, we actually have V and A, right? Both of them. We have the or, we have each one, and so now we just need to rewrite these as probabilities and solve for our unknown. So if I wanted to rewrite this, I could add this and subtract this, right? So we could add this on both sides. So we have probability of A and B. Maybe I'll do A, V, and H for varsity and honors. Equals to, and then I can take probability of varsity plus probability of honors, and then I'm going to subtract this one, right, to move it to the other side so we can cancel this one out. So minus probability of A or B, V or H. Sorry about that. Well, once you do that, we have literally all of this information already, right? So probability of varsity is 74 out of the 200 seniors. We're going to add 51 honor roll seniors. And then we have to subtract varsity or honor rolls, which is 113 over 200, right? And so once you add this up, then you get 12 over 200, divide by 4 and 4 will give you 3 over 50, which is equal to 6%. This one's for you to try, okay? So it should be the exact same way. See if you can get an answer. We'll check it in just a moment. Hopefully you got 9.5%. We are going to move on to example 4. This is your practice problem for example 4. You're going to do it after the notes. So our last example is, what if we have more than one probability? Okay, so the American Diabetes Association estimates that 8.3% of the people in the United States have diabetes. Suppose that a medical lab has developed a simple diagnostic test for diabetes that is 98% accurate for people who have the disease and 95% accurate for people who do not have it. The medical lab gives the test to a randomly selected person. What is the probability that the diagnosis is correct? So the thing is, we don't know if the random person has diabetes or not. Or not. Okay? So we need to consider all of the possible scenarios. Ready? So here's your person. If they have diabetes, there is, and then they could also not have diabetes, no diabetes. Okay. So then we know if you have diabetes, then there's two potential possibilities, right? It could be accurate, and get it right, and it could be not accurate. And then if you have diabetes, it's a different percentage for accurate. Oops, sorry. And not accurate. So let's take a moment and put in what we know. So of the people on the earth, 8% have diabetes. So that's your 8.3% here, right? Which means that this percentage is 91.7% do not have diabetes. So far, so good? If you have diabetes, your diagnostic test for people who have the disease is 98% accurate, which means that it's 2% not accurate, right? And then the accuracy for people who do not have it is 95%, which means this is 5%. Okay? So let's take a moment and just figure out what's the probability that the diagnosis is correct. Ready? Probability of getting a correct diagnosis, okay, equals the probability of having diabetes, right? So in order for you to get a correct diagnosis, you could have diabetes and accurate. But it's not just accurate, because accurate is both of these. You have to say accurate given that you have diabetes. And the other option is, what if you have, probability of, and it's all going to be the opposite, right? If I don't have diabetes, no diabetes, and it is accurate given no diabetes. Sorry, I ran out of space there for sure. Okay. So what is the chance of this happening? Well, and means we're multiplying, correct? So we're going to have two kinds of probabilities that we're going to add together and multiply. So the probability of having diabetes, oops, so sorry. So this is like saying, I'm going to write it all out. Ready? Probability of diabetes times the probability of accurate given diabetes, plus if I have no diabetes, then it has to be multiply accurate given no diabetes. Okay. And so let's take a moment. Probability of having diabetes is 8.3%. Sorry. 0.3. Let's just do 8.3. Okay. And then I'm going to multiply it by accurate given diabetes. So that tells you which one of these we want, right? Accurate given that you have diabetes is the 98%. And then we're going to add that to no diabetes. I'll write this over here, is 91%, 0.7%, times accurate if we don't have diabetes, which is 95% accuracy. Okay. If you add that all up, you can do all this math in one, then you get 95.2% accurate. Okay. So even though this 98%, you can't just take 98 plus 95 and find the average, because it's 98% of that small percent, right? So you have to multiply those two together, and then you have to add it to these two being multiplied together. Take a moment and see if you can figure out what the probability is if the diagnostic is incorrect. We'll be practicing in class tomorrow some more.